Hello everybody, this is Cranky Calculus. I'm going to go ahead and do a practice test. It's my Unit 6 I teach, but it's really going to cover applications of derivatives, which is lots of volume stuff, and it's also going to cover the second fundamental theorem, which is really two huge topics. That's usually at least one of these is covered in a FRQ, especially for AB, Calc AB. Sometimes this is two FRQs on the AP exam, so this is some really big stuff here. I'm going to just cover some multiple choice questions and some other, and an FRQ as well. And I'll cover some things in between as well. So make sure that you like and subscribe, and make sure that you go through the description here and go ahead and get these blank practice tests so that you can work on it alongside with me. Our first question here, we have an FRQ. We have the graph of f is shown to the right. It consists of a semicircle and two line segments on the interval from -2 to 6. And we're gonna let g of x equal that integral right there that you see, which is going to be the integral from 2 to x f of t dt. Okay, so what we're going to do here is we're going to first find for part A g of 6 and g prime of 3. So for g of 6, that's as simple as substituting in a 6 into this integral. So from 2 to 6 of f of t dt. All we have to do is do a little bit of geometry here. Now, a couple little things here is we don't have some of these intersection lines. So this right here, you can tell that this is going to have a slope of -4 in order for that to go from the point 4 to 6 -4. So since it's a slope of -4, this intersects here at the point 5. Because of that, this triangle right here, if you do 1/2 base times height, this is going to be 6. This little triangle right here, that's going to give us -2 since we're below. So this is actually going to equal 6 minus 2, which is 4. For the next one, for g prime of 3, in order to find g prime of 3, I need to find g prime of x. So g prime of x is actually going to be the derivative of this integral. And the derivative of this integral of f of t dt is just f of x. So you'll be required to write down that string, not necessarily that whole string, but at least the g prime of x is equal to f of x. You'll be required to write that down for some of the verifications down below. So if we can do it now, get it out of the way, that's great. So now that we know that g prime of x is just f of x, we can know that g prime of 3 is just f of 3, and we have to find the value here at 3, which we don't have. We got to do just a little bit of math investigating here. This is going to have a slope if it's from the point 2, 0 to 4, 4. It has a slope of 2. Okay, so this slope right here is equal to 2. And since it has a slope of 2, you can kind of draw the rest of the way over here. We can cheat just a little bit. We clearly have an intersection here at -4. So this is of the line y equals 2x minus 4. So if we substitute a 3 into there, we're going to get 2 times 3 minus 4, which is an answer of 2. Okay? What intervals is g of x decreasing? So g of x decreasing, we're looking for g prime of x being negative. That's all we care about. Now, we have the graph of f, so we have to relate g prime back to f in order to talk about f. And we can only talk about f. We can't give justifications with g prime. We can only give justifications of f. So first off, we can see that where is f of x less than 0, since they are related? That's clearly going to happen between 5 and 6. So g of x is decreasing on, I always include the endpoints. You can watch one of my other videos to see why I include the endpoints here. G of x is decreasing on 5 to 6 because, and I cannot talk about g, I can only talk about f. And the reason I'm allowed to talk about f is because I know that g prime is equal to f, because f of x is negative. Okay? Some people like to put g prime of x equals f of x is less than 0. That's totally fine as well, but this will get the job done for us. What about concave up? So we're pretty much the same question here. We're looking for concave up with this blue graph that we see up there. In order to do that, I care about g double prime being greater than 0, which means that I need f prime being greater than 0, which means that I need it when the slope of this f is positive. When is the slope of this f positive? Well, it's clearly, I can draw some tangent lines. I'll do that in gray. Positive tangent lines right here. So clearly the slope's positive there. And the slope of this entire segment from 2 to 4 is also positive. So g of x is concave up on, we're going to go from -2 to 0. So from -2 to 0, you can kind of see how we're increasing from those 2 points right there, and from 2 to 4. Because I can only talk about f here. So because the slope of f is positive, or f is increasing. I'll just say f is increasing on those intervals. Okay? At what value of x in between these, so from -2 to 6, does g of x obtain its maximum value? So anytime we're looking for a maximum value, you must think candidates test. We have a couple things that we need to get to for the candidates test. So max value of g means that we need to see when g prime of x is equal to 0. This is always worth a point for the candidates test questions. You do need to state that. And when is g prime of x equals 0 in between the endpoints? Happens at just 2. Yeah, because g prime of x is equal to, no, it's not this 2, 5. 2 and 5. So this happens at x equals 2 and 5. So that's when f of x is equal to 0 as well. So it happens just at 2 and 5. It happens at -2, but it's already an endpoint, so I'm already going to consider that. So I'm going to do my candidates test here. I'm going to consider my endpoint and everything else. Sometimes in these problems, they either give you these values, they're either easy to solve, or you've already solved some of them above. So like g prime of 3, I have that, and that's actually not even important. So let's do it up. So for g of -2, a little bit of side work here. G of -2 is going to be equivalent to integrating from 2 to -2 of f of t dt. There's no prime there, which is the exact same thing because those bounds are in the wrong order, integrating from -2 to 2 of f of t dt. If I'm integrating from -2 to 2, that is a semicircle with a radius of 2, so it's 1/2 pi r squared. We're actually going to get negative 2 pi, because that negative sign right there. Okay, so we're looking for a max value. I have a feeling that's not going to be the max value. G of 2. This one's really nice because we're going to integrate from 2 to 2 of f of t dt, and these are going to 0 out. So this is going to be 0. G of 5. Just kind of show you again where g of 5 is. Okay, so if I were to, I already did this little section up here because I said that this triangle from 2 to 5 is 6, so I already did that part. This is 6. And now I just need g of 6, which I did that already up here. So I already did g of 6, so I can go ahead and copy and paste that down to here. So we have a max of 6, and that happens at x equals 5. The answer to the question was only asking for x equals 5. I'll give you all the information so that you all have it. And that's going to wrap up. That's not too bad for our FRQ. Pretty straightforward. So that's our FRQ. And now let's go ahead and move it on down to our multiple guess section. Go ahead to do this first multiple choice question here. It says determine the area of the region bounded by f of x and g of x on this interval from 0 to 3. It is helpful if you know how to graph this. I'm going to do a quick little sketch. It's not always necessary, but this one it might be necessary. I have a feeling it is going to be. To graph this f of x, I do not have zeros at 0 and 3. I'll just do tick marks. 1, 2, 3. So this is for f of x. I'll do this one in red. So you can see, looks something kind of sort of like this. And then let's do this next one in blue. Sketch this one. I mean, if I take out an x here, you're going to see it's 3 minus 2x. I'm going to have zeros at 0 again, and at 2/3. Sorry, 3 halves, which is right there-ish. I'm guessing. And this is a downward parabola. That means I'm going to have an intersection somewheres around here. How do I find that intersection? Well, let's set f of x equal to g of x. So we're going to get x squared minus 3x is equal to 3x minus 2x squared. I'm going to move everything over to the left-hand side. Looks a little bit easier to do that if I add the 2x squared to both sides and subtract 3x from both sides. I'm going to get 3x squared minus 6x equals 0, and it looks like I'm going to be intersecting here. If I take out a 3x, x minus 2, so it intersects here at x equals 2. Okay, so this one is lame and a half here because I'm going to have two different partitions. Because when I sketch this, you can clearly see I'll do my partitions here in orange. I have a partition here where blue's on top and red's on the bottom. And I have a partition here. I know I didn't graph all of it, and that's going to go all the way until 3. So I'm going to have blue on top here. So when I find the area, so I'm going to integrate from 0 to 2 of blue on top, which is going to be 3x minus 2x squared minus x squared minus 3x in parentheses dx, plus integrate from 2 to 3, and now this is when red's on top. This is going to be x squared minus 3x minus 3x minus 2x squared. All right, so I don't want to make this video too long. So pretty much here's the setup right here. Okay. I'm going to tell you right now, if you were to solve for this, you should get 4. Just that little section right there. If you were to solve for this one right here, which you can try on your own, you should get an answer of another 4. These actually both are 4. So your answer here is actually going to be 8. It's your job to go ahead and verify that. This is up to you to figure this one out. I set everything up for you. Y'all should be good. I don't want to make this video too long. All right, let's go ahead and move on to the next one here. Number 3, if f of x is equal to this integral function right here, you can kind of see it. The bounds are variable. Then f prime of x is equal to, so let's go ahead and take the derivative of this. We take the derivative of this, don't forget, we're going to actually substitute that right into there, and then times the derivative of our bound. Okay, so when I substitute that in right here, I'm going to get f prime of x is equal to square root of x cubed plus 1 squared minus 1 times the derivative of x cubed plus 1 is going to be 3x squared. This does not look like one of my answers, so it's not a big deal. I can go ahead and use my arithmetic here, my arithmetic skills. I'm going to get x to the 6th plus 2x cubed plus 1 minus 1 times 3x squared, which is going to leave me with the square root of, what we got here, x cubed plus 2x, sorry, x to the 6th plus 2x cubed times 3x squared. I have a GCF in there because they're not matching up yet. I'm starting to kind of see which one it's going to be. I can kind of tell right now. But I can take out an x cubed, which is going to leave me with x cubed plus 2 times 3x squared. And then from here, ooh, not the prettiest here. I just noticed there's a typo on my notes here, so I'm going to fix that all before I publish everything. But that choice D should be an extra X at the end of that one. It happens when I make these tests. Typos happen. So now I'll be able to match this answer up. Before I really couldn't, but now I totally can. So what's going to happen here is I'm actually going to rewrite this. So this is just x squared times x to the 4th plus 2x, because I can't pull out an x cubed inside of a square root, but I can pull out an x squared, which is going to give me the absolute value of x times x to the 4th plus 2x times 3x squared. Since x squared is already going to be positive no matter what, this is equivalent to saying 3 absolute value of x cubed, because x is always going to be positive because it's because of the square root. X to the 4th plus 2x, which is going to give me an answer of D. All right, sorry for the confusion. Life happens. Oh man, I can tell you right now, this is one of the tougher tests I've given because I'm just looking at this question right here, and I know that this one is a toughie. Woo! Get ready for it. So this question was actually an old FRQ from quite a long time ago. I just rewrote it as a multiple choice question for my students last year, and man, it is a doozy. So let's go ahead and do it. The figure below shows the region in the first quadrant bounded by the x-axis and the graph of f of x, which gives us like f of x, but not exactly what f of x is. It's for some c is in there. So we have this variable c as well, which is a constant. For the volume of this, it's telling us what the volume is. When we revolve this around the x-axis, it's 2 pi. So we revolve it right there. We know that the volume is going to give us 2 pi. So our job is to go ahead and solve for c here. So to find the volume, that's going to be pi times r of x squared, and we're integrating from 0 all the way out to this intersection right here, which I can solve for that. When f of x is equal to 0, just trust me, this is going to happen at 2. You can solve for that yourself. You can clearly see it's going to happen at x equals 2. So we're going to integrate from 0 to 2 of this cx root 4 minus x squared. That's a c, not a parentheses. We're going to square that dx, and that answer is going to be 2 pi. Okay, our job is to solve for this variable right there, that c. Okay, so real quick, pi's cancel out, and I'm going to get the integral from 0 to 2 of this cx square root of 4 minus x squared. Whoop. There we go. Dx is equal to 2. Before I integrate this, I can distribute that squared sign. So I'm going to go from 0 to 2. Oh, it keeps happening to me. Of c squared, x squared, 4 minus x squared, because the square root's going to cancel out. Dx is equal to 2. That c is not part of the integral. It's actually going to pull it out right out in front. So it's c squared. And then this right here, this integral is a number. I'm going to distribute that x squared if you don't mind. Okay, so it's c squared times a number equals 2. So I'm going to figure what this integral is, and then we'll do 2 divided by that, and that'll be our answer. And we'll be good to go. We'll square root both sides first for c. But so anyway, c squared is going to be, let's check in my work here. Yeah, 4/3. Make sure I didn't mess up as I go through this video. 4/3 minus 1/5 x to the 5th. Evaluate that from 0 to 2 equals 2. Substitute in a2, we're going to get c squared times, what's nice is you plug in the 0, it's going to 0 out for the second part, so I'm going to just plug in just the 2 here. I'm getting 32/3 minus 32/5 equals 2. From here, it's just all algebra. Again, for the sake of the time of the video, I'm going to help you out here, and I'm going to tell you that I'm going to get B as an answer. So from here, it's up to you to go ahead and finish that algebra. It's not hard to do, just annoying. Okay. Next one is a lovely integral problem. This test is loaded, so no complaining from anybody that's taking the test onward, because I don't think I've made a test this tough in quite a while. Okay, so for this one right here, in order to integrate this, man, looking at it, it looks like an arc sine, I'm guessing here, arc sine. And because it's arc sine, I actually want to do a little bit of splitting this thing up. Okay, so what I do want to see here, because I'm just looking real quick, and this is what my brain is. I'm like, oh, well, u equals x squared minus 6x plus 34. du would equal 2x minus 6 dx. And I don't have that. That's not going to cancel out. But because of that square root on the bottom, I'm like thinking to myself, this might be an arc sine or arctangent. It's a square root, an arc sine question. So, tell you what if I made this minus 6 right up there? Okay, in order to make that a minus 6, I need to take away 1 and then add 1. So this integral is equivalent to 2x minus 6 plus 1 all over this denominator right here. Now I can split this up into 2 integrals. So I'm going to get 2x minus 6, and I did a lot of the hard stuff here for this first integral. Plus the integral of 1 over this right here. Okay, So on this first part, I'm going to split this up into two questions really, and I'll combine them all at the very, very end. This first part, I did this u sub. This is just the integral of du over root u. Did. So this is just 2 root u. 2 root u. So this is 2 square root of x squared minus 6x plus 34. Like I said, did the heavy lifting on the first part. This next part right here kind of looks like arc sine, but it's not in the form that we need. So let's go ahead and complete the square here. Let's cut that negative 6 in half and square it. I'm going to get 9. I want in the denominator there to be an x squared minus 6x plus 9. In order to get that plus 9, I'm going to split up that 34 and add a 25 over here. The reason I do that is I now get this integral where I get x minus 3 all squared plus 5 squared. This is mathematically equivalent to what I have right above it. And then from there, I'm just using a formula where we have arc sine. So arc sine, that's the one without the anything in front of it. This is going to be arc sine of my u value, by the way, is x minus 3 for my formula that I should have memorized. Is going to be arc, well, not just arc, but maybe put a sign there. So arc sine x minus 3 all over a value, which is 5. And then we're going to go plus c that thing and just put this all together, make this look nice and pretty here. And there's this tough problem getting it out of the way. Alright, so now we got all the non-calc stuff done. Let's go ahead and move on to the calculator section. Our calculator section here, there's nothing tricky. You don't need to see me input anything in the calculator. Y'all are totally capable of doing these problems on your own. I'm just going to set it up and I'll tell you what the answer is and we'll just kind of go from there. So a vase has a shape of a curve obtained by this y equals 2 plus sine x from x equals 0 to x equals 5. X and y are measured in inches. What is the volume in cubic inches of the vase? So it's kind of nice to know what this graph looks like, just so you know what we're doing, because we're going to go out to 5. Again, you can graph this on your own. I'll just tell you what it looks like because I know what sine looks like. It's something like this-ish. All right, you can type this in your calculator. You can get from here to here. And what we're trying to do is it's being rotated about the x-axis. So when it says about the x-axis, that just means rotated about the x-axis. So we're going to find this partition right here. And it's going to be that blue curve, which is the 2 plus sine x. So my radius is 2 plus sine x. So my volume here is pi, integrate from, totally from 0 to 5, of my r of x, which is 2 plus sine of x, all squared dx. That's it. From there, you type that in your calculator, and you're going to get, I got 80.115. Another answer of D. Go figure. All right, last one here, which is calculator. Zoom in out here. The base of a loudspeaker is determined by 2 curves. We have our 2 curves right there, the x squared over 10 and negative x squared over 10, from 1 to 4, shown below. For this loudspeaker, the cross sections perpendicular to the x-axis are squares. What's the volume? So in order, this is a cross-sections question, so to find the volume of a cross-section, you have to integrate the area, so you have to first find out what the area is. So for a square, we have s squared, okay? To find s, here's my partition for s, that blue line. So it's actually going to be big minus little here. So my s is going to be this x squared over 10 minus this negative x squared over 10, which mathematically we can equate that to be x squared, 2x squared over 10, which is x squared over 5. So to find this volume, we're going to, I'm going to come back down here, volume. It says we're integrating from 1 to 4, so we're going to go ahead and do that from 1 to 4. Of my area, which is s squared, so area of x is going to be x squared over 5 squared. You can simplify this if you want on your own, but you do have access to your calculator, so that's why I advise you just let your calculator do all the work from here. And we're going to answer of 8.184, and that is going to wrap up our video here for our whole review. I know there's a lot more stuff out there, but this is just the questions I asked on my test. This is what I valued at that time, so this is a good little start for you for your studying, and best of luck to you.